The National Electrical Code Section 314.17b requires that electrical conductors be secured and supported in an approved manner. This includes using connectors to connect conductors together and to terminate them to devices. Connector manufacturers typically recommend the use of anti-shorts, also known as wire knots, in conjunction with connectors that have insulating bushings. This is because even connectors with the insulating bushings can still allow for the possibility of accidental contact between the conductors. It is considered best practice to always use anti-shorts when connecting conductors, regardless of whether the connector has an insulating bushing. This provides an additional layer of protection against short circuits. Anti-shorts help to maintain a tight connection between the conductors, preventing the conductors from becoming loose and making contact with each other. Insulating bushings can become damaged or dislodged over time, allowing for the possibility of accidental contact between the conductors. Anti-shorts provide an additional barrier against this occurrence. Using anti-shorts is a simple and effective way to meet the requirements of the National Electrical Code and ensure the safety of your electrical installations. Therefore, it is always advisable to use anti-shorts when connecting conductors, even when using connectors with insulating bushings. Firstly, protection from loose connections is enhanced. Anti-shorts help maintain a tight connection between the conductors. This prevents them from becoming loose and making contact with each other, which could lead to a short circuit or other electrical hazards. Secondly, the prevention of accidental touching. Insulating bushings can become damaged or dislodged over time due to various factors such as physical stress, environmental conditions, or improper installation. If the bushing fails, it can create an opportunity for accidental contact between the conductors. Anti-shorts provide an additional barrier against this occurrence, reducing the risk of short circuits. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Compliance with the National Electrical Code is essential for ensuring the safety of people and property. Several sections of the National Electrical Code are relevant to the use of anti-shorts with MC cable connectors. Section 300.4 addresses protection against physical damage. It requires that conductors be protected from physical damage, which can include damage from sharp edges, abrasion, or impact. Anti-shorts can help to protect conductors from physical damage by providing a smooth, rounded surface that prevents them from coming into contact with sharp edges of the connector. Section 314.16 covers box fill calculations. This section specifies the maximum number of conductors that can be installed in an electrical box. Anti-shorts can affect box fill calculations because they take up space inside the box. It is important to consider the space occupied by anti-shorts when determining the appropriate size of the box. Section 330.40 pertains to boxes and fittings for metal-clad cable type MC. This section requires that MC cable be properly terminated in boxes and fittings that are designed for use with MC cable. Anti-shorts are typically used in conjunction with MC cable connectors to provide a secure and reliable termination. The NEC does not explicitly require the use of anti-shorts in all situations. However, it emphasizes the importance of protecting conductors from physical damage and ensuring that connections are secure and reliable. Using anti-shorts is a common and effective way to meet these requirements. Always consult the latest edition of the National Electrical Code and local electrical codes for specific requirements in the area. Local codes may have additional requirements or restrictions that are not covered in the National Electrical Code. Always follow the manufacturer's instructions for installing MC cable connectors and anti-shorts. The manufacturer's instructions will provide specific guidance on the proper installation techniques and torque requirements. Proper installation is essential for ensuring a safe and reliable electrical connection. Several different types of anti-shorts are available, including twist-on connectors, crimp connectors, and push-in connectors. Each type of connector has its own advantages and disadvantages. The best type of connector for a particular application will depend on the size and type of conductors being used, the environmental conditions, and the installer's preferences. Twist-on connectors, also known as wire nuts, are the most common type of anti-short. They are easy to install and relatively inexpensive. Twist-on connectors are available in a variety of sizes to accommodate different numbers and sizes of conductors. Crimp connectors provide a more secure and reliable connection than twist-on connectors. They are installed using a crimping tool, which compresses the connector around the conductors. Crimp connectors are often used in applications where vibration or other factors could cause twist-on connectors to loosen. Push-in connectors are a relatively new type of anti-short that is becoming increasingly popular. They are easy to install and do not require any special tools. Push-in connectors are available in a variety of sizes to accommodate different numbers and sizes of conductors. When selecting anti-shorts, it is important to consider the size and type of conductors being used. The anti-short must be sized appropriately for the conductors to ensure a secure and reliable connection. It is also important to select an anti-short that is compatible with the type of conductor being used. For example, some anti-shorts are designed for use with solid conductors, while others are designed for use with stranded conductors. Always inspect anti-shorts for damage before use. Damaged anti-shorts should be discarded. When installing anti-shorts, be sure to follow the manufacturer's instructions carefully. Improper installation can lead to loose connections, short circuits, or other electrical hazards. Over-tightening can damage the conductors or the connector. Under-tightening can result in a loose connection. Be sure to use the correct torque value as specified by the manufacturer. After installing anti-shorts, it is important to test the connection to ensure that it is secure and reliable. This can be done using a continuity tester or a multimeter. A continuity tester will indicate whether there is a continuous electrical path between the conductors. A multimeter can be used to measure the resistance of the connection. A low resistance reading indicates a good connection. In addition to using anti-shorts, there are other steps that can be taken to prevent short circuits in electrical installations. These include using proper wiring techniques, protecting conductors from physical damage, and ensuring that all connections are tight and secure. Proper wiring techniques include using the correct wire size for the circuit, avoiding sharp bends in the conductors, and routing conductors in a safe and organized manner. Conductors can be protected from physical damage by using conduit, raceway, or other protective measures. Conduit is a rigid or flexible tube that is used to enclose and protect electrical conductors. Raceway is a channel that is used to route and support electrical conductors. All connections should be checked periodically to ensure that they are still tight and secure. Loose connections can be caused by vibration, temperature changes, or other factors. Loose connections can lead to short circuits, overheating, or other electrical hazards. Consider the environment where the electrical installation is located. In damp or corrosive environments, it is important to use anti-shorts and connectors that are rated for wet locations. These connectors are designed to resist moisture and corrosion, which can damage the conductors and lead to short circuits. Properly grounding electrical systems is crucial for safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock and prevent damage to equipment. Anti-shorts do not directly contribute to grounding, but they are an important part of ensuring that all connections in the electrical system are secure and reliable. Regular inspections of electrical systems are essential for identifying potential problems before they become serious. Inspection should be performed by a qualified electrician. During an inspection, the electrician will check for loose connections, damaged wiring, and other potential hazards. If any problems are found, they should be corrected immediately. When working with electricity, it is important to always follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and de-energizing circuits before working on them. De-energizing a circuit means turning off the power to the circuit at the breaker or fuse box. Always test the circuit to make sure that it is de-energized before working on it. Electricity can be dangerous, but by following safe work practices, you can minimize the risk of electric shock and other hazards. Furthermore, consider the specific application when selecting anti-shorts. For example, in high-vibration environments, crimp connectors may be preferred over twist-on connectors due to their superior resistance to loosening. In corrosive environments, corrosion-resistant connectors should be used to prevent deterioration of the connection. For high-temperature applications, high-temperature rated connectors are necessary to withstand the heat. When working with aluminum conductors, it is important to use connectors that are specifically designed for use with aluminum. Aluminum conductors are more susceptible to corrosion than copper conductors, so special connectors are needed to ensure a reliable connection. Aluminum connectors are typically made of aluminum or a bimetallic material that is compatible with both aluminum and copper conductors. Some connectors are marked with the letters AL or CUAL to indicate that they are suitable for use with aluminum conductors. In summary, while connectors with insulating bushings offer a degree of protection, relying solely on them without using anti-shorts is not considered best practice. Anti-shorts provide an additional layer of safety by preventing loose connections and accidental contact between conductors, especially when bushings become damaged or dislodged. Adhering to industry standards and manufacturer recommendations by using anti-shorts helps ensure code compliance and enhances the overall safety and reliability of electrical installations. By following these guidelines, you can help prevent short circuits and other electrical hazards.